Good morning. Myself Somyajit Nayak from Kochbiar Government Engineering College. Currently, I am studying in Electronics and Communication Engineering. Today, I am discuss about signal and system. Topic is different types of signal. Now, let's start the topic. So, first of all, we need to know about what is signal. A signal is a function of one or more variables that indicate some usually physical phenomenon. Signals serve as carriers of information between communication devices. They can convey different types of information depending on the application required. Let's see some example of signals. Human voice and sound waves, digital music recording, accelerometers measured with accelerometers in mobile phones, force measures with force sensor in robotic systems. Now we classify the types of signal. In the basis of time domain classification, we can classify signals in two parts. One is continuous time signal and another is discrete time signal. Now let's discuss about continuous time signal. So what is continuous time signal? A continuous time signal is a function defined for all the time values within a given interval. It's characterized by having a value for every instant of time, making it a continuous function of time. A continuous time signal denoted as x of t where is a function where the independent variable t can take any real value within a specified interval. Let's see some example of continuous time signal. Sine waves, voice recordings are the examples of time domain example which is continuous time signal. Let's see the graph of continuous time signal which is similar to sine wave. Let's discuss about discrete time signal. A discrete time signal is a sequence of values that are defined only at specific distinct points in time. It's typically represented by integers. A discrete time signal is often represented as x of n, where x represented the signal's amplitude or value and n is the time induced. Example of discrete time signal is daily temperature reading, digital audio, digital image, etc. Now here you see the graphical representation of discrete time signal. Next we discuss the basis of amplitude classification. We can classify the signal analog signal and digital signal. Now we discuss analog signal. What is analog signal? An analog signal is a continuous signal that represents physical measurements by varying its amplitude, frequency or phase modi over time. Analog signals can take on any value within a given range, making them continuous and representing information in a non-discrete way. Example of analog signal is sound waves, light intensity, etc. Given below is the analog signal graphical representation. Now, one other is digital signal. What is digital signal? A digital signal is a representation of information using discrete, distinct values, typically binary digits 1, 0 and 1. Digital signal has defined labels that represent data points. This discrete nature makes digital signal less susceptible to noise and easier to process and transmit, especially over long distance. Example of digital signal is digital audio like MP3s, signals in microcontrollers and microprocessors. Now, the basis of periodicity classification, we can classify signal into two parts. One is periodic signal and another is non-periodic signal. Number one, periodic signal. A periodic signal is a signal that repeats itself exactly after a specific time interval called the period. This means the signal's pattern of values is the same over each period. A continuous time signal xt is considered periodic if x of small t plus capital T equal to x of t for all time t, where capital T is the period. Example of periodic signal. A sine wave is a classic example of a periodic signal where the waveform repeats itself every 2 pi radians. Now we discuss about non-periodic signal. So what is non-periodic signal? Let's see. A non-periodic signal, also known as aperiodic signal, is a signal that does not repeat itself at regular intervals, unlike periodic signals which have a defined fundamental period. Non-periodic signals lack this repeating pattern. They are characterized by their randomness or unpredictable behavior over time. Now see the example of non-periodic signal. So what is the example of non-periodic signal? Speech waveforms, random noise, and signals generated by unpredictable events are the example of non-periodic signals. On the basis of energy and power classification, we can classify signals into two parts. One is energy signal and another is power signal. So now we discuss energy signal. So what is energy signal? An energy signal is a type of signal whose total energy is finite and non-zero, while its average power is zero. This means the signal exists for a limited duration or decays repeatedly enough that the total energy can be calculated and is not infinite. Energy signals are often aperiodic. For a continuous time signal xt, the energy is calculated as E equal to integral x of t square dt. For a discrete time signal x of n, the energy is calculated as E equal to x of n tar whole square, summation of x of n tar whole square. Example: a signal pulse of a finite duration and a decaying exponential is the example of energy signal. Now let's see what is power signal. A power signal is a type of signal characterized by a infinite average power and infinite energy. In simpler terms, it's a single signal that delivers a non-zero finite amount of power, but over an infinitely long period of time its total energy would be considered infinite. For continuous time signal, average power p equals to limit t tends to infinity 1 by 2t integral minus t to t x of t whole square equal to dt. For discrete time signals, average power p equal to limit n tends to infinity 1 by 2n plus 1 integral n equal to minus n 2n x of n square dn. Now see the example of periodic signal. The example of periodic signal is periodic square waves sinusoidal signal. Number 5. On the basis of symmetricity, we can classify the signal in two parts. One is symmetric signal and another is antisymmetric signal. Symmetric signal is also known as even signal and antisymmetric also known as odd signals. Now let's see what is symmetric signals. A symmetric signal, also known as even signal, is a signal that remains unchanged when its time axis is reversed. Mathematically, for a signal xt, this means xt equal to x of minus t. In simpler terms, a symmetric signal looks the same whether viewed from left or the right of its center point. Example of symmetric signal. Consider a simple discrete time signal where x of 1 equal to 2, x of 2 equal to 5, x of 3 equal to 8. For it to be symmetric, we had to also need x of minus 1 equal to 2, x of minus 2 equal to 5, and x of minus 3 equal to 8. And now we see what is antisymmetric signal. So what is antisymmetric signal? Antisymmetric signal, also known as odd signal, is a signal that exhibits a specific symmetry property. In simpler terms, it's a signal where the value at a given time is the negative of the value at the corresponding time in opposite direction. Mathematically, it is expressed as x of t equal to x of minus x of minus t for continuous time signals, and x of n equal to minus x of minus n for discrete time signal. Now see the example of antisymmetric signal. So what is the example of antisymmetric signal? The sine wave sine t is can antisymmetric signal because sine of minus t equal to minus of sine t. Now we classify the signal on the basis of predictability. One is deterministic signal and another is non-deterministic signals. So what is deterministic signals? A deterministic signal is one whose behavior is completely predictable and can be described by a known mathematical function or formula. So what is the example of deterministic signals? The example of deterministic signal is sine waves, cosine waves, square waves, and signals defined by specific equation are deterministic signal. Now we see some characteristics of deterministic signal. Number one, it can be reproduced exactly at any given time if the function is known. Number two, no uncertainty about the signal value at any given time. Number three, it can be modeled using mathematical equation. So now another we discuss non-deterministic or random signal. So what is non-deterministic or random signal? A random signal is one whose behavior is not predictable in advance and cannot be described by a simple mathematical formula. So what is the example of non-deterministic signal? The example of non-deterministic signal is noise, pitch signals, and signal representing chaotic systems are random signals. Now we see the some characteristics of non-deterministic signal. Number one, uncertainty exists about the signal's value at any given time. Number two, must be analyzed using statistical methods like probability, distributions, mean, variance, etc. Number three, cannot be reproduced exactly even if the statistical properties are known. So last one is the basis of causality. Causality, we can classify the signal in three parts. One is causal signal, and number two anti-causal signal, and number three non-causal signal. So first of all, we discuss about causal signal. So what is causal signal? So a causal signal is a signal that is zero for all negative time values. In simple terms, a causal signal only exists for time values greater than or equal to 0. So what is the mathematical expression? The signal x of t is considered to be causal if x of t equals to 0 for all t less than 0. The example of causal signal is signals that are 0 for negative time. Number two, signals whose values at negative time instants are undefined. Now we see anti-causal signal. So what is anti-causal signal? An anti-causal signal is a signal that is non-zero only for negative time values and 0 for all positive time values. So now we can say mathematically a signal x of t to be considered as anti-causal if x of t equal to 0 for t greater than 0. So now we see example of anti-causal signal. So what is the example of anti-causal signal? A time reversed unit step function often defined as e of minus t is example of anti-causal signal. Number three, non-causal signal. A non-causal signal is a signal that has been that has non-zero values for both positive and negative time, meaning it exists for both past and future time. Instant relative to a reference point. Mathematically, it can be represented by if belongs to t less than 0 such that x of t not equal to 0. So what is the example of non-causal signal? So a signal defined for minus 3 less or equal to n less or equal to 4 is non-causal because it has values for both positive and negative part. Now conclusion of this topic So, in conclusion, signal classification is a fundamental aspect of signal processing involving the categorization of signal based on their properties. Understanding signal types is crucial for selecting appropriate processing techniques and tools. Various methods, including time domain frequency and time frequency analysis, offer a comprehensive approach to signal analysis and classification. So let's end the topic about types of different signal. So thank you.